All right, good evening, everybody. We will get started in just a couple more minutes. All right, we will get started. Thank you for joining us today. This meeting is being recorded and we will share out the link afterwards. I have enabled microphones for you, so if you have a question, please feel free to do that. I'll also be monitoring the chat as we go through um, the training today. So we're going to take a look at the new software from LEGO Education. The software is very similar for both the Mindstorm EV3 and the new Spot Prime. There are some differences, but for the most part, there's a lot of similarities. We're going to look at the EV software in particular, because that's what many teams have if you have an existing robot. So we'll take a look at that. So this is the screen that you will get when you install it. And if you are going to get it, you can go to legoeducation.us/downloads. If you have a Windows computer, you can download it from the Windows Store, and that will you can download it from there. So, all right, so let's just take a look at this. I'll do just a little bit of a tour. This is the home screen when you first get into it. And there's a couple different things here. One of the things you'll want to pay attention to is the unit plans. In the unit plans, there are a number of different things that you can use in your classroom for training. If you go into the robot trainer, this will include lessons on how to do turns, objects and obstacles, grab and release, colors and lines, sets of basic line following instruction, and some different different tutorials here as they're learning how to manage the robot. Now, this does use the basic interface, or the basic robot that comes as the default that you've probably seen before. There are some teacher resources here, so definitely check that out as well. All right, in the build area here, this is where there are a number of, and if you remember the book that came with the EV with build instructions, it was difficult to hang on to and to keep everything in line in there. If you look into the, this has the driving base. So if I click on this one here, it'll take me into the instructions like what's in that book. And let me go ahead and back out of here. And then here is the cuboid, and if you want to build arm with a medium motor that you're used to seeing. On a training robot, here are the instructions for building that arm. And of course, there are other sensors available as well. So everything is built right into the software. And there's other robots that you can build for educational purposes as well. All right, so let's go ahead and take a look at the program itself. When I'm on this screen here, I have my recent projects down here, and I can create a new project. And I can also come to projects, and this is where I can view all the projects I have. And if on this little edit icon here, I can select a particular program, and down here at the bottom, I can duplicate it, or I can rename it when I come into here. If I want to create a new project, I'm just going to click here on new, and this will put the new project, the project programming window. I'm going to zoom in on this just to make it a little bit easier to see in a webinar. And this is the start block. If you've done EV3 before, give me just a second. Right, if you've used EV3 before, you're used to having a little start block. That's what it's similar to. On the left-hand side, you will see different programming. This uses a Scratch-based programming style. So if your kids have done Scratch, or you have been involved with Scratch programming with your kids, this will be very familiar with how you navigate and how you work the different, how you work well. So notice on the left here, there's different colored dots, and each one of these dots corresponds to a particular type of programming block. So the blue is motors. These blue blocks, these all deal with motors. If you are just wanting to control mode at a time. When you go to movement, these blocks deal with movement. So think of this as the old tank mode, or what was the other? These different modes that you're used to seeing actual driving. It's not movement motors. Then there are display ones that will change what is output on the display. Of course, you have the sound ones that kids like to play with. These are events, and we'll come back into these. So basically, these are things that will start or end the program, or a particular set of commands. So this lets you run more than one thing at a time, and I'll come back and take a look at that. Then the next thing you have, just slightly, it's very similar, but it's just slightly darker yellow, is the control. This is where your wait commands are for. This also has your repeat commands for your loops, and it has your if-else commands, if and if-else commands. And it also has a stop command, and this is what's always very useful to have, is to say, you can say stop and exit the program, you can stop just the stack if you want to. But this is kind of the end the program block comes in there. Then as we keep on going down, here are your sensors, the sensors that you have available to you. And then we're going to have our operators. So operators are math. Well, it can do math. So this is a plus. This will add the two values. So if I put a 5 here and a 3 there, it's going to give me the result that will be 8. And of course, you can put variables in here as well to work with that. Then there's comparison operators. So this is a less than. And of course, you have equal to and greater than. And an or operators are also helpful, and a few others. Then when you come down, and then when you come down to the last two are variables and my blocks, and we'll come back to those in just a little bit right now. So somebody's saying they see anything. You should be able to see my screen I'm sharing right now. So we'll check the chat here. Yeah, you should be able to see the screen that's being paired. Let's just pause and make sure that everything's working okay. All right. How this happens to operate. So first, we're going to take a look at movement. A couple of things we need to do. We're starting with movement in here. First of all is we want to set our movement motors. So if you recall on your EV3, you have 4 ports A, B, C, and D, which are your motor ports. And in this command finds, it says that the default, of course, is that the motors are plugged to ports B and C on your robot. And you need to actually tell it that. That's always a good thing to do. And some other blocks that you can do in here, this one will set the movement speed. So if you tell it to move, it'll set the movement speed to 50%. The default is 100%. And those are kind of the basic ones. So, and you necessarily have to do the movement speed. I'll show you some different ways that you can do that as well. Then we're going to say, drop this one here, and this is going to move forward for 1 rotation. And just like before, in the old blocks, you can change this to degrees or seconds, and I don't recommend they're using time, because time is dependent. The distance it travels in a specific period of time is dependent on the strength of your battery. So that's usually not a good thing to use for that. But I prefer, but you could rotations, and with the rotations, say 1.25, so it would be 1 1/4 rotations of the motor. Or I could also come to degrees, and I could say 75 degrees, or I could say 60 degrees for 1 full rotation of the motor. And that works well. So that's the basic programming there. That's one block. So that's one of them. Now, there's some other ones that you can do. This one here, let me just come back to this one. So on this one, I can say move forward or move backwards. So you'll notice this one just goes straight line forward. You don't have any other options. So this one, though, this one here, if I, this is the, you've seen this, this is if you've done programming for right 100, then the robot's going to turn in place. Or I can say, oh, I want to turn about this far. And then how far to go, the number of rotations or degrees as it's moving forward. So that's another option you have as well. This one just starts moving straight, doesn't tell it how far it's going to go. And then you have a stop move. Let's take a look at other ones here. This one, we mentioned before, you don't always have to set the speed, because in this particular case, this is just like the one we had here, except this one now includes the speed in it as well. So not only telling it the direction I want it to go, straight or a turn, how far I want it to go, also telling it the speed that I want it to go. All right, so this is the other one that I wrote. This I'm telling it to go a particular distance, but for these parameters here, I'm telling each motor, my left motor and my right motor, I'm telling them what speed I want them to go. So in this case, it's going to go straight. If I set this at a -50, it's going to turn in place as it moves. If it's at 0, that motor is going to be stopped, and the right motor is going to go forward, making it do a sweeping left turn. I kind of personally might have, but it's really, it's just my personal preference, because I feel like it gives me a little bit more control there. And then this is very similar. In this case, it doesn't tell how far, what speed each motor is going to go, and tells it to go ahead and start moving there. So, all right. So that's some of that, some of the basics of moving. If you were to just do one motor up here, a single motor, of course, then I can say, all right, take motor A and run clockwise for one. This just does one motor. This usually this you would use for moving your arm up or down, or some kind of attachment, but usually not for driving. All right, so so that's similar, just to give orientation to that. So one of the questions, of course, is how to connect to the robot. I'm going to go ahead and turn my robot on here, and I'm going to hopefully get this all connected. And let's see if my camera works correctly. All right, so there is the robot. All right, and it just turned on, so it's now ready to go. And I think I just lost the feed. Try this again. Camera just turned back off again. All right, here we go. All right, so hopefully you can see the robot in the corner of the screen there. Okay, so so how do we connect to the robot? Well, up here is a connect button. Now, you still have the ability to connect with the wire just like before, but you also have the ability to connect with Bluetooth. Now, I will say something about the Bluetooth connection. Sometimes Bluetooth works perfectly. Sometimes it's very difficult to get it to connect. You just have to, remove it from your computer and put the Bluetooth connection back in, and then sometimes delete it back in and back and forth until it works correctly. Robots, so the Bluetooth technology, has been a lot of advancements in the Bluetooth technology since these robots were designed. So the new Spike Prime, it works almost flawlessly. In fact, I've never had any real issues at all with the Spike Prime, but with the EV3, there have been challenges with connecting it. So I click on the connect button here, and it will come up here and it will kind of walk me through what I need to do to connect to Bluetooth, which is basically you want to make sure the first two options are on in the Bluetooth menu, and then you're going to go ahead and pair your brick. Now, my robot has been paired before, so it's fairly easy to do in this case, but I'm going to go ahead and connect to it. I really like the idea of, let me just make sure it's connecting. Oh, let's go. I need to say it's over here to connect to it. And all right. Like we said, sometimes it's a little bit of a challenge to connect to it. I've had mine connecting before, and sometimes it does not connect. Okay, so one thing you can try with this, let me change my screen sharing here just a little bit. So if you come to settings on your computer and go to devices, you should see here I have the E3 that's paired, so I can remove this device. Sometimes removing the device and putting it back in will there we go. So sometimes that's what it takes, is to remove it and put it back in, and then it will connect to it. So you'll notice a couple things just changed once I did that. First of all, the little brick icon in the top left corner here turned to a green dot, which tells me the brick connection is open. The other thing that happened is that it shows any sensors or motors I have in their current state live here. So that's a really useful thing for programming and diagnosing what's going on. And also click on this one, and this gives me a live view of this and what firmware and what the battery power is. It's 100% right now. And I can click on there's three little tiny dots over here, and this is where I can can rename my EV3 if I wanted to rename this particular EV3, and it would connect. It would rename that brick and connect to it. I do recommend renaming your EV3s and labeling them somewhere. You don't want it to. You want it to be someplace it's not visible for competition. But it does help to have them labeled, and so you know which one people are connecting to, so they're not all called EV3 and you have several in your classroom. If you only have one in your classroom, it's fairly simple, but if you have more than one, it's able to rename them. Now, when I look at this motor, I can select different options of what I can view. Current view is degrees. I could switch it to rotations or the current speed of that motor if I needed to kind of monitor that as it's running. All right, so let's try this, and let me just double check here. Okay, yeah, I just want to make sure you still see the robot there. So we're going to try what we did before. I'm going to designate motors V and C as my drive motor, and I'm going to tell it to straight, or I'm going to tell it to move for one rotation at 50% power for each one of these. Now down here in the bottom right corner, I have one is just download button. For this one, you can download to it, and you might have heard its little song play there. I can download to that one, and it will then be on the robot, just like you're used to. This one will download it and run the program. And there it goes, off and ran for one rotation. So it's just that simple. Now you notice the program is still running, and I'm going to go ahead and manually stop it. And because if I don't want that to happen, I need to come here and put a control and exit program in there. I'm going to make a little modification here. I'm going to make that a -50. This should make it turn in place. And I'm going to go ahead and run it. And you'll notice when it's done, it's going to go back to a run command here, because now I've told it to stop and exit the program when it's done, when it comes to the end of that. There you go. So it completed that task and then exited the program. So this is an important block to put in place, because otherwise it comes to the end of this command, it doesn't know what to do, and the program continues to run. And you can manually. Now, I would just want to make an observation about Bluetooth before I go any farther with this. And that is that if you're running Bluetooth, remember that when you go to competition, that you cannot, when you're at the table, you cannot control your robot with Bluetooth. That's okay for running when you are running in your, as you're practicing before you go to competition. But when you go to competition, you need to be using a cord, and you cannot tell it to run from there. So the kids need to know how to navigate the menu just like they always have, and run their programs that way, because that's what they'll do at the table. This is certainly convenient because I don't have to have that plug in that wire every single time I want to make an adjustment to my robot. All right, so that's a basic overview. Let's talk other things here. So I'm going to I'm going to take this off. I'm going to delete this one, and I can right click on here. The other nice thing, I can duplicate the block. So if it's left there, I want to grab another one just like it, I can right click and say duplicate, and then I can say, all right, that's where I got that block. Or I can right click and delete a particular block, which is what I'm going to do here for right now. And I'm going to come back to my movement blocks. And in this case, I'm going to tell it just to start moving straight. And I think this will work. Actually, let me turn this around. All right, I'm going to have it start moving straight. And I'm going to come down to my control, and I'm going to grab a wait until command. So this wait command is going to be, there's something has to go this. So we didn't know what. All right, so what I'm going to do is I'm going to come to my sensors now, and I'm going to wait until the color sensor, actually maybe I won't, because my color sensor actually is not plugged in, I just realized. So let me just do a quick adjustment here. I can use a color sensor. Sorry about that. Let me go over here. Give me just a sec. Apologies. Realized I didn't have my color sensor. Will that allow me to use my color sensor? All right, and I'm going to go ahead and plug that into port 3. And what port 3, you'll see that it just showed up on the screen there. And all right, so I'm going to go ahead and set that down there, and I'm going to wait until the color sensor sees blue, because I have a blue line on the floor. And then I'm going to come back to movement, and I'm going to tell it to stop moving. So this will then, it should start moving straight until it's line, and then stop moving. Let's see if it works. There we go. And it stopped and ended the program right there. So that's a simple way to do that. There are some more advanced ways of doing this as well. It should another approach. This would be if I do a loop. I can say do this loop, and I'm going to take until the color sensor is blue. And what I'm going to do is tell this, let me break these apart so I can use the pieces. So I'm just going to tell it to start moving straight over and over and over again. And then I'm going to put this here. All right, let me just kind of, now notice what I did with that one block here that I don't want to use. I showed you I can right click and delete the block. The other thing is I can just drag it and drop it anywhere over here. It doesn't have to be any place in particular, and that will throw that away. So what this will do is this will keep doing whatever is inside this loop command. It could be a series of commands, and this is basically how you do line following in general. But it'll keep doing this over and over. So it's just going to start moving over until that condition is met, and then it's going to, once that condition is met, which is it sees blue, after the repeated loop, and the next command is a stop moving command. So let me grab it and move it back. And we're going to see that this will work as well. The same effect, very similar programming to that. And that's kind of how that works. So let's say that you had a bunch of programs like this. You had this set of programs that you were going to use over and over and over again. And you didn't, every time you do this, you didn't write that set of commands. So line following programs are good for this. There's other kinds of things where this is the case. So what you can do then is you can actually do a my block. So I'm going to actually, I'm going to take this block away though, and I'm going to use a different block for this because I'm going to actually tell it the speed that I want it to go. All right. So I can use a my block for this. So when I come down here, option right now to say makeup, this is going to come, this is going to go move to line. This is what I'm going to call this my block. And I'm going to add an input to it. And this input is going to be speed. So I can pass the speed to it. All right, it's very for this, but this will get this done. Now, this now created this new block here called, this is your my block, what's defined. And what I'm going to do is I'm going to take this and drop this into here. All right. So this is the commands that I want to happen. Now, the other thing, notice I have speed here. Shape of this shape matches these two shapes here. I'm going to take this and drop it right there. All right. So this is going to, whatever that is, let me show you where. Now, once also notice here in my blocks area, I now have a new called move to blue line. And I could take this and drop it into here. Now, what this will do is I can set this to, I'm going to go ahead and set it to 60, so it'll go a little faster than it did last time. Bring the robot back, and we're going to go ahead and run this. And what we'll do is, well, it's going to say move to blue line at 60. It's going to run this, and it knows that 60 speed, and it's going to send the speed into here, into this variable rate. So that's the speed it will run to. So I'm going to go ahead and run this. May not have noticed, but it did go a little faster than last time. And that's a way you can do that. Now, what if I wanted to add a different thing to this? Let me right click here and edit this. And I'm going to add one more input, and I'm going to do color. So now I'm going to have one more, and I'm going to save this. So now here I'm going to put blue. I haven't actually tried this before. This should work. And then color, I'm going to drop right there. So let's see if this works. I haven't done this in this particular programming language, so it might be a glorious success. Yep, it was a failure. So evidently it did not pass that blue along to that. I think there's a different way. It maybe have to be something else that I need to pass on to there. Let me take this out. And there's probably a different way of passing on besides typing in the word blue to that. I know in the old program, these were actually numeric values that you passed on. So I'd have to do some checking with that. But you can, the point is that you can pass on multiple variables as parameters, what we call parameters for this. Fancy word for a my block in programming. All right, let me share another thing in here. All right, and that is, it's also really valuable to add comments. So if I right click on the screen, I can say add comment. And I'm going to go ahead and right click here. I'm just going to click here, say add comment. And here's a comment I can put in. So right beside here, I can add some information, right? What's actually supposed to happen in this program. So that's always a useful thing. That's something that judges look for, is whether your code is comment. Write what is supposed to be going on in a particular part of the program. It's one of the reasons the judges look for it. It's a really good programming technique all programmers use, because a couple things. One is you can work on a program and come back 3 or 4 weeks later and you have to rethink everything. It's just not fresh in your mind. Also, sometimes programmers work on teams where one programmer may write an initial program, and then later on someone else comes in to edit or modify that program, and it speeds up the amount of time it takes them to work on it. All right, I'm going to go ahead and come here, and I am to delete this color out of there because that did not work. And now that's no longer there, and I still have just the move to blue line. All right, so that's a little bit of an introduction to my blocks, which is a really useful thing. So a couple things that are really good for your students to use as they're programming would be decisions, and my block, can get them to do that, and to use some sensors. Those are all very valuable things. It's not very difficult for them to do. Give them a little bit of challenge to figure it out. And if you're not sure the programming. The tutorials will have some basic programming interface for that, as well you can go to ev3lessons.com, and that's also another great where you can send kids to find some pretty good programming tutorials on how to do specific things. So definitely take a look at that as a resource as how to do that. So let's go back to. All righty. I'm going to go ahead and block. I guess I can't throw it away that way. Okay, I'm sure. Hold on. I have never thrown away my block. Oh, okay. So I have to take everything out of the my block. Then I can throw away the my block. Oh, and it's being used somewhere. There we go. Now I threw it away. All right. So let's come back to here, and I'm going to, let's see here. I have the movement motor set. You just tell it to move. Straight at this speed. And then I'm going to come back to my sensors. Oh, I'm sorry, I'm going to come to my control. And I'm going to say wait until. Now I'm going to come to my sensors and speed. All right. And then I'm going to tell you back to my movement, tell it to stop moving. All right, so we're back to this basic program here that we had before. All right, so in events, there are several different events that you can have. So I can, for example, one of the things I can do is every time the color sensor sees blue, for example, I can have it do a particular. I'm going to have, let's see, I'm going to have it display. Let's do we're just going to do this. I think you can see it. Hold on just a second. Let me grab the robot. All right, so you should be able to see that. And just to make it a little bit more interesting, we're going to do the sound. We'll just have it say hello, which is always a fun thing for kids to do. And then we are going to tell it one other thing on the control. I'm going to tell it to stop this stack when it's done. So that stack will finish. It's going to go forward, and it's going to have just a few fun things when it's finished. So let's see how this works. Okay, and it didn't quite work the way I expected it to, but this will start another stack, and we definitely play around a little bit with that and see how that works. But this will basically start basically runs another whole set of programs while it's doing that whenever that condition is met. We'll play around. All right. All right. Take a little bit of time for some questions. I see Christina is asking if anyone is using Spike Prime having trouble getting the color sensor to detect reflected light instead of color. I know I haven't heard of any problems with that, but I know with reflected light, it's important to calibrate your color sensor. You can look online for some tutorials on how to calibrate your color sensor. That might help you with that because it does make any difference. The other thing is make sure that you have come in. It'll be very similar to this, where you can take your sensor and change it to reflected light. You can see what the value is as it's coming through. You're going to have that value. The other thing that the color sensor is close or too far away from the surface, the color sensor has a hard time detecting the reflected light or the particular color. So that's a couple ways to check. All right, if you have questions, feel free to put it in the chat, or feel free to unmute yourself and ask a question. All right, well, if there are no questions, hopefully you found this helpful. You should have a microphone button at the top of your screen. You have a microphone button up there that you can click on to unmute yourself. Actually, let me take that back. Somehow the settings didn't get set. If I had allowed mics and it didn't allow mics. Let me get this saved. Hopefully this will work this time. Okay, should be the microphone active.
Okay, can you hear me?
Yeah.
All right, so I'm the one who asked the question about the Spike Prime color sensor. So what's happening is, you know, those little icons at the top where you can see, like, if you're on color, you can see what number you're at for the color.
Right up here. Mm-hmm.
Yeah. So it's stuck on color, even though our program is supposed to be using reflected light. It's still just giving us those numbers of 1 through 10. It's giving us, yeah.
Right.
Instead of a
if
percent.
you click, right, but if you click on the little icon, connect icon here to show your brick, and change what it shows, because what it displays there doesn't necessarily have anything to do with what your program is programmed to sense. But so here, this one is set to color. It's a 2. So for example, in that program I was trying to work, I probably should have put a 2 in there, and I think that would have worked for the format instead of typing in blue. But I can change it to reflective light, and it can show that it's reflective light of 20, so that way I can see that. And now I'm going to pull it back, and you can see now I'm on a lighter surface. I now have a reflected light of 98 or 89, so that just changed there. So I could have actually programmed this to go for reflective light instead of color as well.
Okay.
Your EV3 will have that same. Correct. And then that will change once you exit out of here. Now that change will show up here. So I'll just to show you again, I'll go back to color, and it says 6. I have no idea what 6 is. Which I guess it's white. It's kind of on I guess it's a light surface. So that just changed what displays here as well.
Okay, thank you.
Yep. All right, any other questions? All right, well, if there are other questions, hopefully you found this useful. This is a fairly easy interface for the app to. There are some changes, but it's a fairly easy interface, and it is what they're more used to. And I think it's probably a better interface than the old EV3 programming. At least old programming with all the little wires and passing information back and forth was a little bit challenging to figure out for the kids that wanted to do advanced programming, where this is a little bit easier for them. So, all right. So with that, we will let you go. Thank you very much, and have a good evening. And let us know if we can help you in any way.